Hi, everyone. We are currently reviewing the concept of interior angles within a polygon and how to find their angle measures. First, let's make sure that we understand interior angles and what they are. So any polygon is a multi-sided shape that I'm kind of looking at here on the screen. I've got a quadrilateral, I have a pentagon, I have a hexagon. It's a many-sided shape. So anything from three sides and up is considered a polygon. So I am looking at these angles here that are marked. They're not necessarily marked congruent. I just have them marked because these are the interior angles of each of these polygons. So these are the interior angles of the polygon. Let's also take a quick look at the exterior angles of a polygon. So if I were to draw an extension of any side from one of the sides of a polygon, like this red mark here is an extension of that side, I have now created an exterior angle. That is an angle that is formed between the exterior of a side and the extension from the other side. Same thing here. This is another exterior angle. And so is this. Now, if I were to draw all of the exterior angles going all the way around, I would find that the number of exterior angles is the same as the number of interior angles of each of these shapes, which also matches the number of sides of each of these shapes. For example, if this is a pentagon because it has 5 sides, I know it will have 5 exterior angles. It will also have 5 interior angles. So let's look at how we find the sum of the interior angles of any polygon. The formula for that is n minus 2 times 180. N actually represents the number of sides. So make sure that we understand that n is the number of sides. The number of sides is also the number of angles, both interior and exterior. So n can represent either of those. So for example, for this quadrilateral, which is a 4-sided figure, the n number is 4, right? So if I plug in the number 4 into this formula, n minus 2, that would mean that it's 4 minus 2. So 2 times 180 gives me a sum of 360. So what I'm saying here is if I were to add all of the angle measures of the interior angles, the sum would equal 360. If we have a pentagon, then we have a 5-sided figure. So I would plug in 5. So n minus 2 is going to give me 3 times 180. And 3 times 180 is 540. So the sum of the angle measures of these interior angles is 540. Likewise, if I have a hexagon, that's a 6-sided figure. If I plug in 6 into my formula here, I'm going to get 6 minus 2. So that would give me 4 times 180, and 4 times 180 is 720. So the sum of all of the interior angle measures here is going to be 720. Now, that is different than when we are looking at the sum of exterior angles. If you were to go all the way around and add up all of the angle measures of the exterior angles, then what you would get is 360 no matter how many sides you have on the polygon. It's always going to equal 360, and we have discussed that. If you need more explanation, then you should look at some other videos that sort of put this together for you. So let's take a look at what we just talked about. What's the sum of the interior measures of a 36-sided polygon? All right, so we know that the sum will always equal n minus 2 times 180. So our figure that we're looking at here has an n number of 36, right? It's 36-sided. So that means that if I plug in 36 minus 2 times 180, I'm really just multiplying 34 times 180. And so when we do that math, 34 times 180 is going to be a sum total of, that's not 34. Let's try that again. 34 times 180 is going to have a sum total of 6,120. That's how much, that's what you would get if you were to add up all the interior angles of a 36-sided polygon. Now, let's do this problem together. What is the number of sides of a regular polygon? And I'm going to underline regular. With one exterior angle whose measure is 24 degrees. Now we have to keep in mind that a regular polygon is a polygon where all of the angle measures on the interior and the exterior are going to be equal, meaning all interior angles are the same measure, all exterior angles are the same measure, and all of the sides are the same length. So let's go to our understanding of the sum total of an exterior. So we know that the sum of an exterior, the sum of the exterior angles, right, is always going to equal 360. All right. Now, if one of them has a measure of 24, then all we have to do is take our total sum and divide it by that measure of 24, and that will give us the number of sides. So when we use our calculator, or handy dandy calculator, 360 divided by 24 would give us 15. And so this is a 15-sided figure. All right. So we're using the information we know about the sum is always 360 for the exterior angles divided by the equal measure of 24 that's been distributed to each of those exterior. So let's take a look at example problem 3. We are trying to find the measure of one interior angle of a regular 20gon. So this is a 20-sided figure and it's regular, so that means that all of the interior angles are going to be congruent to each other. So we can take the total sum of the angles. We can take the total sum of the angles and just divide it by the number of sides, which is also the number of angles. So the sum, of course, we know is equal to n minus 2 times 180, and that'll be divided by n. In this case, if n is 20, then what we are going to be multiplying with 180 is going to be the number 18. And of course, the number of sides is 20. So I'll just replace those values here to do the math. All right, so 18 times 180 divided by 20. When we do that math, we're going to get, make sure that I have that right, 18 times 180 divided by 20 is 162. So each of those angles, so one angle measure will be 162 degrees in this case. All right, another problem that we should work with is finding the number of sides when we are looking at a regular polygon, where each interior, I think it's missing the word angle here. So where each interior angle measure is equal to 168. So we're trying to find how many sides there are. That would be n. We're trying to solve for n. But this is also a regular polygon, so each angle is congruent to each other. So that's kind of cool because that means that all we have to do is sort of reverse the process there. Now, there is a long way to do this. It is saying that n minus 2 times 180 divided by n equals 168. That's one angle measure. Multiplying both sides by n in order to cancel out the denominator of n here. And that would give us, on the left side, when we distribute that 180, it would give us 180n minus 360 is equal to 168n. Then we would subtract 180n from both sides, so we get negative 360 is equal to negative 12n. Then we just divide negative 360 by negative 12, and n will equal 30. Okay, so it has 30 sides. This is a 30-sided polygon. So a 30-sided polygon is the answer to this question. Now, there is a quicker way to do this, and I want you to all see how that looks. So let me take this stuff off. Now, what we did in that math was we ended up with 168n. We ended up with 168n is equal to 180n minus 360. I think we had it on different sides, but anyway, what we ended up having to do there is find the difference between 180n and 168n. And so we know that that's where we got that negative 12n is equal to negative 360, and then we just divided by negative 12 to get our 30, right? Well, if we just think about finding the difference between the given angle measure and 180, which is this 12n on the left, right? If all we do is find the difference between 180 and the given angle measure, we can divide that difference. We can divide 360 by that difference. So what I'm saying is that the same math here would be to say, all right, I know that 168 degrees, I know 168 degrees there is actually 12, has a difference of 12 between 180 and 168. So what I'm saying is I would go, all right, 180 minus 168, right, is equal to 12. I know I need to distribute that number, divide that number from 360 to get my answer. And if I divide 360 by that difference, I'll get my answer, which is 30. Let me write that a different way. So what we're saying is just divide 360, right, by the difference between 180 and the given angle measure. If you do that, you'll always get the right answer. So you're going to divide that by the difference between 180 and the given angle measure. So just subtract the given angle measure from 180 and then divide 360 by that number, and you will always have the right answer.